So let's look at some other problems here. I go ahead and I select this. People are acting strange today. I don't know if it's because it's Monday or what it is. Yes.
Today is Monday. So say at the beginning where it says x to the fourth.
Yeah.
If it would have said x squared, it would have only been 2 instead of 2.
Yes. So good. So let's actually look at something that's very similar to this. So let's say you had x squared minus 13x plus 36 equals 0. So notice this looks a lot like the one that we had started with, but now it's just a quadratic. So it's the same thinking. It's saying, okay, what adds to 36? Sorry, what multiplies 36 but adds to negative 13? And that is 9 and 4. Or sorry, negative 9 and negative 4. So you would only have the solutions x equals 4 and x equals 9. If we had this as an example. Good question. All right, so number 17. We're going to go over maybe a few more of these from this absolute value inequalities packet. At the very end, the graphing? At the very end when you graph?
Yeah.
Okay, so yeah, let's go all the way to graphing. Let's go all the way to graphing. So let's do a couple of these as a class. All right, so would anyone like to do this? Yes?
Yeah.
Do you need to know? Amara, would you like to knock this one out? If you could kind of slow it down a little bit and explain it, that'd be awesome. Yes. Maybe this is supposed to be due today. Mm-hmm.
Okay. So,
we can make it due tomorrow because the quiz is going to be. Quiz I'm going to move to Wednesday because I want to have enough time to cover enough sample problems for each of the topics.
So I don't remember the name that you called it, but I know that
It's okay.
gotta like bring it down.
Absolute value minus.
Yeah. 22, and then right here.
Hold on.
Wait. Is it an or?
Hold on. What's the first thing we do though? What's the first thing we do?
Yeah. I'm tripping. Hold on. So,
Okay.
Yeah, can you do that?
yeah.
Yeah, it's safer to just go ahead and make sure you isolate the absolute value first.
Now.
Okay.
Now you can whatever.
Yeah.
So b minus 8 greater than and 12.
Okay.
And then
Yeah, once you isolate it, then you're going to make your two different inequality statements.
and this is or
That's a good question. It is or, and why is it or?
because it doesn't have a
Because if you look here,
it's greater than
it's greater than.
I just see it off if it has a business.
I wouldn't do it from here because what if you're working this down to isolate this, and at some point you have to flip the sign? It's based on right before you wrote them. Of course, this one doesn't matter.
Yeah.
But it's because this is greater than, it's an or statement. Good.
Okay.
So greater than or greater than or equal to.
Now we add the 8 to both sides.
Please don't fall.
And then you get B is greater than 20. And then you get B is less than 4, negative 4. And then we do, you want me to do the line too?
Yeah, so go ahead, the directions say to graph, which they do, so go ahead and please graph it.
Okay. I don't really know how to remember that too.
Okay, so now we're at the graphing part, okay. So this is an OR, so let's go ahead and write the word OR between those two, no, between your two inequalities that you wrote. Yeah, there you go. Okay, and let me just for the sake of notes, let me just go ahead. So this is OR because this here, yeah, that's what makes it an OR statement. Okay, so now to graph this. So you have B is greater than 20 or B is less than negative 4.
I know it's open,
It is open.
but are we going out?
Well, B is greater than 20, right? Because the crocodile alligator wants to eat the larger piece of meat.
Yeah.
So we say that B is greater than 20. So if B is greater than 20, which direction would that be compared to 20? It's greater than 20. Yeah, greater is going towards positive, any good. And then the other one says B is less than negative 4. So there you go. Good job. Marcus, good job. Fantastic.
Good job, Sonny boy. Like, I get it now. He said B is greater than 20, so it can't connect because it's greater, so it has to be something more than 20. And then it's less than 4, so it can't go behind 4, it has to be greater, like, or
Less
I mean, it has to be less, yeah, less than 4.
Negative 4, but yes.
Yeah, negative 4.
Yes.
I have a question.
Yes.
How do you like I understand how to do that part, but like how do you know whether the segment is open or closed?
Okay. The way you know is because it says greater than, not greater than or equal to.
Okay.
Right? When you have the greater than or equal to part, then it's filled in.
Oh, yeah.
Yes, Caleb.
Are you gonna ask for explanation on the book?
No, I wasn't. Yes. Yes, you may. Alright. Would anyone like to see another one of these? Yes.
Me.
Another one that's worked out? Okay.
Which one?
Which one would you like to see?
Oh, it's not the paper.
Yep, one of those from the sheet. Sure, 21.
Oh, can I do it? Can I do it?
Sure.
Oh, wait a minute.
Alright, Jeremiah, you want to do 21? You can do 21.
Yeah, I'll try it.
You got it?
I have faith in myself.
I think you got it. Let's go for it.
Okay. Let me see it. What, it's just like this one here?
What's the first step?
What do you have to multiply by 2?
Yeah, because you're trying to do what?
Get that. Yeah.
Yeah, you're trying to get the absolute value by itself with the absolute value bars. Yeah, so you're going to multiply both sides by 2. Okay? Multiply both sides of the inequality, not you just multiply the same side by 2 twice. So just be careful. There you go. So you multiply the left side by 2, the right side by 2.
Yeah. And then
And so what do we have
this
now?
cancels out, right?
Yeah, it becomes 1 and 1. So what do you have?
Right?
Well, you multiply both sides by 2 though.
Oh, that's
5 times 2. Okay, and you still have the absolute value bars. And it's 2x plus 3, not 2x plus, it's 2 plus 3x.
I didn't even put that. I swear I know.
Okay. So notice all she did was she first got that absolute value of 2 plus 3x by itself. That's what you want to do. Now, from there, you're going to write those two inequality statements.
Yes.
But yeah, from that. And this is going to be an or and and.
This is an and.
What makes it an and?
Yes. But I thought.
It's an or. Greater than is an or. So this thing you might have to, you guys
Wait,
should
didn't you just-
definitely.
Didn't- Oh, never mind.
Yeah, so greater than or greater than or equal to is an or statement. So you already know this guy's gonna look like this, where it's 2 raised because it's an or statement. It's gonna be 2 split up like this.
So it's gonna be like the last one.
Yep.
Okay.
No.
Oh, I don't want to do this.
Let's make 2 statements from whatever's inside of the absolute value bars. Just leave it like that. So one of them would be 2 plus 3x is greater than or equal to 10. That's one of them.
And then only the 2 plus 3x is less than or equal to 10.
No, less than or equal to negative 10.
Yeah,
You want to write it there because you want to write it side by side. Get that number. So next line down. No, without the absolute value bar. Because now you're dropping it. Now you're dropping the absolute value bar. And you say, okay, I'm going to make 2 statements without the absolute value bars. Or the other one. Or 2 plus 3x is greater than or equal to 10. Okay, good. So I want to emphasize to you guys, let's make sure we do the whole thing. Let's not try to do it all in one line. Let's actually, from here, we're going to make 2. What you have is good.
No, yeah, I'm making more space.
Okay, so she's going to go ahead and from there, she's thinking, I'm going to make 2 inequality statements from that statement. 2 separate statements. Good. And then now you can solve each one of those individually.
Negative 10 minus 2.
Negative 10 minus 2?
8.
Negative 12. Here. Think about which way it's jumping.
Can't see that?
Yeah, negative 12. Okay.
Am I doing 12? Do I do this right? This is negative 4. I think I'm going to say this.
And then, yeah, then she divided by side by 3. C divided by 3 divided by 3. Thank you.
Oh, the thing was, okay, I thought like, never mind.
Alright, so good job. Alright, awesome. So, this looks good. So, yeah, divide by 3, divide by 3. So here, x is equal to, actually is equal to, like, 2.6 repeating, right? Because it's like 2 2/3. And this is good, so less than or equal to, there was no flipping, right? There was no division or multiplication by a negative the whole time, so everything was good, right? Okay, so this was an or statement.
Yeah.
So I was hoping you would write that. So if we got from here, whoops, we got from here, we say, okay, this is an or.
Or
This is an or statement. So this or this, right? Because what you have written right now is kind of implying that it could be this
or that.
and it depends on how you read it. But if you write or, you know it's definitely an or statement, it's not an and.
And statements are the ones.
Because this would be impossible to be less than -4 and at the same time, greater than 2.6 at the same time. So we write or, it's okay, we're safe. Okay?
And if it's the other way.
Yeah, and happens when you have your absolute value, whatever, is less than or less than or equal to. So we're here. That would be your solutions. This or that. And then to graph this, we need to graph this. We can go -4, and -4 is here, and then 2.6 repeating is here. I know it's kind of not the best looking graph. But then less than or equal to, so is that going to be filled in or open?
That's gonna be filled in. That's gonna be filled in.
It's going to be filled in because it can actually, it can be less than or equal to, it can be -4, so we filled in. And it's going to the left, good. And then x is greater than or equal to 2.6 repeating, which is also going to be filled in,
And
and
then
it's
to the right.
to the right, so that would be the graph. That's not good, let's not do that. That's part of the student.
Can we see a, and statement?
Okay, so an and statement?
Like number 12?
It's still pencil one.
Or number?
Here's one, number 18. So number 18, we have the absolute value of x minus 4 over 5 is less than or equal to 2. So because, well, first off, let's isolate first. Because it's especially important, if you had a negative coefficient in front of this absolute value, and you end up flipping the sign, this and or statement is based on right before you write your statement. It's right after this guy has been completely isolated, so let's be careful here. So this is an and statement because I have less than or equal to, so it's an or statement. Or sorry, an and statement. And it's an and statement, so I know it's going to look like this at the end. It's going to look like a line segment. Because the distance has to be less than 10. So that's less than 10 from the right, can't go past 10, and then going out in the negatives, that value cannot be greater than -10. Sorry, it can't be less than -10, sorry. It's going to be within those boundaries. So as soon as you see that, you know it's going to be an and, it's going to look like this. So you go ahead and write x minus 4 is, you can write the first one, x minus 4 is less than or equal to 10, and x minus 4 is flip the sign, greater than or equal to -10. And then simplify each one individually. So x is greater than or equal to -6, and x is less than or equal to 14. So you can, I'm fine with you guys leaving it like this, or if you want to write it as a compound, you can go ahead and write it as a compound. You could even, if you want to do this, you could write it like this, that's fine. You don't have to. And then now to graph this, because x must be greater than or equal to -6, filled in, but at the same time must be less than or equal to 14. So less than, greater than makes the line segment. Any questions about this one, number 18?
Can you come
Graphing which one?
The ones like this.
Okay. Norman, do you understand the graphics?
Yeah, I can.
Can you help with it? Yeah, I mean, you guys can, if you guys want to work on something on your own, I was going to go over now and go over some other ones that you need to know for your quiz. So, like, if you look at the review, what it's going to go over.
Are we allowed to use this one, please?
Use what?
Use paper. You should allow.
Yes.
Where was I going? I have no idea.
Wait, sir, I was going to look at some other stuff. So right now we're just looking at absolute value inequalities.
Okay.
The other stuff I think is fairly simple compared to what we're looking at now. If you guys remember how to solve compound inequalities, they're going to feel like a piece of cake compared to what we're doing.
What's it called?
So compound inequality, that is something like,
Is that what we did for one?
here's an example of compound inequality on page 185.
Oh, that's easy. That's easy.
Right.
Yeah.
You know, you have 6 is less than x plus 2, which is less than 8. Whatever you do to one part, you make sure you do to all 3 parts. So you subtract 3, so you do that to all 3 parts. So 3 is less than x, which is less than 5. Doesn't have you complete this sheet. So we have this going on. So yeah, that's fine. So if you know, if you have this down, make sure you write this down. If you know compound inequalities, you know how to solve linear inequalities. Like you know how to solve something like this. Negative 6 is less than x plus 2, which is less than 5. Then you know how to solve something as simple as this. Right? This is just a more complicated version of that.
And what about the bottom?
The bottom one is what we've been doing right now. Absolute value inequalities. That's all the ones we've been doing. This whole sheet is absolute value inequalities. Which these are probably the toughest ones on the quiz. The ones we're doing right now.
So all of this is going to be on Wednesday?
And this
Yeah.
sheet has all of that.
Right.
No. This sheet is just absolute value inequalities. If you want to see where else in the book we're talking about, like solving equation quadratic form, you can see on page 165, example 6. Linear inequalities, again, these are very simple. You guys might not even need to study these. You might feel, okay, I know this and compound easy. But maybe you do need to study the ones with fractions. We'll go over one of them next. We saw the linear inequality containing fractions. Does anyone need more time on this page?
No.
Okay, so if we look at, I mean, technically this one would contain a fraction. That was involving, I think, absolute value. But if we look at something like, let's see, that contains a fraction technically. Okay, here's one solving linear inequality. Okay, this one might look scary at first. This is page 185, number 50. So you got 6 times x minus 1 minus the whole value 4 minus x is greater than or equal to 7x minus 8. So this is an example of solving a linear inequality. Okay, it happens to be written out kind of strangely, but what you would do is you would expand everything, combine like terms, and see where you go. So if you expanded everything, now this student, they didn't expand the second one yet, that's fine. They went ahead and distributed the 6, you get 6x minus 6. They still have the minus 4 minus x is greater than or equal to 7x minus 8. Then the next step they did was they decided to add 6 to each side, no problem, you can do that. So you have 6x minus this is greater than or equal to 7x minus 2. And then I think now the student decided, okay, now I'm going to distribute the negative, so I'll have 6x minus 4 plus x is greater than or equal to 7x minus 2. And then now the idea is to get all your constants on one side and all your variables on the other. So the student went ahead and added 4 to each side. That got rid of the negative 4, so now you have 6x plus x is greater than or equal to 7x plus 2. Next line down, student went ahead and combined like terms. 6x and x is 7x. And this is still 7x plus 2, yes?
So if you want to practice solving linear inequalities, you just go to one.
Yeah, page 185 has plenty of. Yep. Yes.
Why did you change it from where it said 6x minus in parentheses 4 minus x is greater than or equal to 7x minus 2? Why did you change it underneath that one?
all we did right here was we distributed the negative. Like it's technically a negative 1 in front, right? So change the sign, -4 plus x. Jonas?
Okay. Right, for number 19 on this sheet, it says -3 plus, and then it has the little like lines, and then it says n-2 is greater than 5.
Let's get to that as soon as I'm done with this one. We can look at that one. All right, so here, if you kept going, then the student subtracted 7x from each side, and we got a statement that 0 is greater than or equal to 2. No, right? That's never true. This is never true, right?
Right.
So then we can then say that there's no solution to this. We say there's no solution because we made a statement that's never true yet.
Yeah, I want to say, Ron, are you going to put these videos on YouTube before that? Yes?
All the videos currently on, except for this one I'm currently recording. Yeah, they're all already on YouTube.
Okay,
And all the PDFs are uploaded too.
Oh,
So yeah, all this is available, and this one too will be available at the end of today. Any questions about this one? I know it looks like a lot of work, but it's just because the way they gave it was kind of weird looking, but it was linear the whole time. You just expand everything, simplify, move all your x's on one side, all your constants on the other.
Can you
Was it 19 was the question? Yes?
You know what the other one that we need to know?
What's that?
What other lessons do we need to know?
So for quiz 3, you need to know how to solve an equation quadratic in form like the warm-up. We'll go over more of these tomorrow. We'll spend more, because I think these and the last bullet point are probably the toughest parts of the quiz, are the solve an equation quadratic in form and absolute value inequality. Yes? Right, like for example, like the first one that we did for the warm-up, we could have used U substitution, but because it was so straightforward, you didn't have to. And some of you may already realize that you don't have to use U substitution because you get it. But if U substitution is just that one extra step that makes it a quadratic, and then you substitute later on. We'll go over those some more. So these are what you need to solve an equation quadratic form, linear inequalities, solve a linear inequality with containing fractions, compound inequality, and the ones we're just doing right now, absolute value inequality. Yes.
no idea.
If you want a pencil sharpener, there's plenty in that box. Yep, pencil sharpeners are in that brown box in the back table.
Mr. Rose is cool like that.
Can I have an improper fraction?
That's like on top of that. Yeah, on that worksheet there was one like an 8/3, for example. That's fine. You can leave it as 8/3.
Mr. Rose, can we what's my name? Solving.
Then how about a bracket?
Can we do solving equations quadratic form? One of those?
Yeah, we're definitely gonna look at one of those. If not by today, then we'll start looking at this tomorrow.
Okay. And when is this session?
The quiz is Wednesday.
Oh, the quiz is Wednesday?
Yeah, I moved it to Wednesday because I wanted to have enough time to look at least a few of these.
Okay.
Because I want you guys to do well.
You know where I get messed up on when we do the linear equations on that last problem?
This problem here.
Yeah. Right. We did the 7x is greater than or equal to the 7x plus 2.
Yeah.
How did you,
How'd you know what to do?
yeah.
Okay, so the idea that you've had from the very beginning was I want all of my x's on one side, and I want all my constant, just regular numbers on the other side. So I still had an x over here, I had a 7x, so I'm going to subtract 7x from the side to get rid of this 7x. In doing so, you came to something that you knew was a statement that's never true, so boom, you're done, no solution. I would say this, don't fight it. If it comes out to here, you've got no solution, you're done.
Okay.
So I think Amara, she said something about number 21 or 19. Which I may have already 19 here.
90. So, 90.
So 19 was this one here. Negative 3 plus the absolute value of minus 2 is greater than 5. So the first step is to isolate the absolute value with the bars, yeah? So to do that, I'm going to add 3 to each side. Add 3 to each side, I get the absolute value of n minus 2 is greater than 8. Now I'm going to go ahead and create my two inequality statements because I've isolated my absolute value. And because it's greater than, it's going to be an or. It's going to be those two rays that are split. It's going to be an or statement. So I can say n minus 2 is greater than 8 or n minus 2 is less than negative 8. It's the same thing when you do an and, when you just, okay, you write the first statement that looks just like the way it's written without the bars, and then you write the other one without the bars, flip the inequality sign, and then change the value to its opposite, to the negative. The same process, no matter which one you're doing. Just know that this one's going to be an or. Now solve for each one individually, adding 2 to each side. So I get n is greater than 10, or n is less than negative 6. And let's say you forget whether it's an and or an or. This can't be an and. I can't have a number that's greater than 10 and at the same time is less than negative 6. So you know it naturally is an or. So that would be your answer, and then if you had to graph this, it would look like this. Less than negative 6, so an open circle left, and then greater than 10, open circle right, 10. Yes?
So and and or statements are always correct with a variable, whereas the one that you just saw earlier with no solution is going to be one that has two numbers.
The one that was a no solution, that was not even inequality. That happened to be so that was not absolute value. That was just a regular inequality.
Oh, okay. So for these, then we're always going to get.
You will always create two statements. Good question. When you get to this point, you automatically create two statements. All right, let's look at, I think we have about 4 minutes left. I want to look at, we've looked at a lot of these absolute value inequalities. You guys have plenty of problems to look at as samples. Let's go to look at one of the other most difficult part, which is the solving equations are quadratic in form, like the warm-up. So if you have a book on page 169, if you don't, I'm going to write on the board anyway, page 143, or sorry, page 169, number 43. So, page 169.
Is this for what?
Number 43. This is solving an equation that's quadratic in form. So this is an equation that is quadratic in form. And number 43 reads 9x to the fourth is equal to 25x squared minus 16.
So we subtract minus 2.
What I would do is I like my largest coefficient of my largest term, the x-squared, to be positive. So I'm actually going to subtract. I'm going to subtract 25x squared. I'm going to add 16.
Okay.
Just because it's nicer, it's more convenient when this guy's positive. So plus 16 minus 25x squared to each side. That would give me 9x to the fourth minus 25x squared plus 16 is equal to 0.
Wait a minute. Question.
Yes.
You're adding 16, but there's not a number.
Yeah, so it's like there's no constant, so 0 plus 16 is 16. Same guy here. There was no x squared, so 0x squared minus 25x squared is negative 25x squared. If things don't match, it's like there's none of that, so it just stays the way it is. You could think of it like that. Okay, so do you guys want to see long AC method or tic-tac-toe method? Tic-tac-toe? I wish I could do both. Okay. You hate tic-tac-toe?
I haven't read it.
Okay. All right. So we'll stick with what I first taught you. That's only fair. It's just crazy to just switch right now on the dime. But if you want to do tic-tac-toe, if you learned it and you love it, go ahead and do it. But let's go ahead and stick to what I've been teaching you, which is long AC. So long AC says, okay, AC is what? AC would be equal to 9 times 16. 9 times 16. Someone have a... Thank you. 124. What's that? 144? 144. Okay. So factors of 144 that added to negative 25. And you go through and you try some. 12 and 12 is going to be negative 24, so that's pretty close.
I don't think there is.
If there isn't, you have to use the quadratic formula, which hopefully we don't.
You don't want the quadratic formula?
I mean, we could. It's just going to be messy, yeah. So we're going to run out of time, but you could treat this. The idea is to treat it like a quadratic, okay? Just keep doing the method you're used to, and we'll pick this one back up tomorrow. When you get down here, you're going to have this. Something x squared, plus or minus whatever, equals 0. So you can treat it just like a quadratic. We
3x squared, like the minus 1.
take out a 3?
Yeah.
I would definitely do that if I could, but 3 is not a factor of 16 or 25. But yeah, that's always a good idea. Take out a greatest common factor if you can first.
You want this paper now?
If you want to turn it in now, you can. Otherwise, I'll take it up tomorrow. Thank you.
So,
9 and 16. Negative 9 and negative 16.
See, I knew I seen it before.
All right, guys.